Hello and welcome to Science Never Stops with the U.S. Space and Rocket Center. My name is David and I'm the Planetarium Director at the Intuitive Planetarium, and tonight we're going to be talking all about moons of the solar system. And the first question I want to get started with, as we're waiting for people to jump in here, is first off, what is your favorite moon? And this is a two-part question. One, I'm interested in your answer, and two, if you answer it, then maybe we'll go there, and that's very exciting, obviously. So as we're coming into view here, you can see that we are indeed looking at our moon, the so-called moon, which is the original, maybe not in terms of its age, although most moons formed around the same time with the entire solar system. But it is certainly the moon that we have known about as humans for the longest, because it's pretty hard to mistake in the sky throughout the month. You can see it pretty much all the time, and even when it's a new moon, you can even see a little bit of the light from sort of glancing off the Earth's atmosphere, hitting the moon, and then reflecting back to us. This is called moonshine. So we actually get a little bit of light from the moon at all times, even when it's a new moon. So that's pretty exciting. So the next question I wanted to jump into before we start to dive into this is to talk about what a supermoon is, since we just had a supermoon yesterday. And this is a term that really gets people up in arms in a good way, I think. They get very excited about when the next full supermoon is going to be, and that's exciting to me because I'm always happy for people to be interested in space, but at the same time, it's sort of a, maybe not a silly term, but a little bit silly to get hyped about compared to normal. So a supermoon is simply it's a full moon, so it's a moon that we can see the full disk of the moon from the Earth, but it's a moon that's a little bit closer in its orbit to the Earth at the time of full moon. So what do I mean by that? Let's back away here. And let me bring up the moon's orbit around the Earth. So a couple things going on. First off, you should be able to see we're centered on the moon right here, and you should see that little dot that is the Earth with the moon's orbit traced around it. No, you can't see this in space. This is us helping you out here. And you can see that it sure looks a heck of a lot like a circle, and it's close, but it isn't fully a circle. It's a little bit ellipsoidal. So what that means is it's slightly an oval. And so you can have an arrangement where you have a full moon and the narrowest part of that oval is going to be sort of lined up. You can have a full moon where sort of a medium portion of that oval is lined up, or you can have the sort of elongated portion of that oval. You can have all these things to happen and everything in between, right? So I guess what I'm trying to say is that the moon can be, tens of thousands of miles different away from the Earth, 10,000 miles different away from the Earth at different points, and this changes things a little bit. So a supermoon is when the moon is within about 90% of what's called perigee, the closest point in its orbit to the Earth. So, all of that said, it is a little bit bigger in the sky. It's a little bit brighter in the sky, but not very much. The difference from a very small moon that would be called a micromoon is about 14% difference in apparent size in the sky and about 30% brightness. And that is not noticeable. And in fact, I'd challenge you to be able to know that it's a supermoon if somebody didn't tell you. I know I certainly couldn't figure that out simply from looking at the moon. If you take pictures, it's noticeable if you compare them sort of side by side. But if you don't, then you can't tell, really. So Any excuse is a good excuse to go look at the moon, so you should do that again tonight. We're one day after full, and it's quite beautiful. It's still quite close, and looks amazing, so go check it out. Anyway, so in tonight's presentation, we're going to look at different moons in the solar system. We're going to start with our moon, but I don't want to spend too much time on it. I want to give you, or anywhere, I want to give you sort of a nice overview of the different places that exist in our solar system because there are very many moons. So I'm still asking you the question, what is your favorite moon? And so far I only see one answer, which is Ganymede, and that's an awesome moon. It's a very big moon, and we'll certainly go there. Now, I want to pause here for a moment. If you take a look at the moon and you're wondering, I really want to know where the Apollo 11 astronauts landed. Where did Neil and Buzz first step onto the moon? Actually, let me even back up a little bit to give you a nice look. And it can be a little bit daunting when you're looking at the moon, but if we find the baby in the moon, I'm not really sure where the man is, but if we find the baby, and I'm quite familiar with those at this point, we have the baby's head right in here. And this is sort of a perspective if it's looking at you kind of from the side, I guess, or you're looking at it from the side. This is its very long nose. This is a little tongue sticking out. And then this is the baby sort of scrunched up, and you know, babies get some gas, and they sort of scrunch up their legs really tight. So this is its back. These are sort of feet in the front. Arms are at its sides, so you can't see them very well. Hopefully this is something that you can find. Let me zoom in a little bit bigger. Maybe it's more obvious. So head, nose, tongue sticking down here, back all scrunched up, lots of gas, something disastrous going on down here, and then feet up underneath it. Well, if you look towards the sort of disaster going on over here, there's actually this region right in here, which is not normally brighter, but I have some higher resolution imagery turned on here, overlaid. We can actually zoom down into this, and this is where the Apollo 11 astronauts landed. And this is a really neat sense of perspective because we're going in from this sort of macro view that we see all the time when we look up at the moon, and zooming in a good bit till we get a lot closer and finding something else. So let's see how well I did this and if I can find the site for you. I have to admit I'm a little bit out of practice since we have been staying at home and I haven't been doing this every day. Let's see. There we go. Okay. So to give you a sense of scale here, this imagery, including the height map, is looking at about maybe 100 centimeters per pixel in resolution. And then you can see a mostly to scale representation of the lunar lander right in there. Pretty exciting. And if we back up just a bit, you can actually even see, it's a little bit hard to see because they're pixelated, but you can actually see the steps that the astronauts took to visit this crater that they almost landed in, and had they crash landed into that crater, it would have been disastrous and really mission ending, and they would not have been able to relaunch. It's a little bit easier to see from back here, but pretty cool stuff. So we can maybe look more at our moon in another presentation. So if you're interested in that, let me know in the comments, and maybe we'll dive into our moon in great detail another Friday night. So let's head on, and we're going to journey to Mars. Now, not all of the planets in the solar system have moons. We started with the Earth because the moon is obviously the most familiar. We are heading to Mars now because both Mercury and Venus do not have any moons, and that's sort of boring and a bit of a bummer for them. And zooming in, oh, that's unfortunate. We just went through Mars. That's a disastrous mission right there. We don't want to repeat that. That's always scary. So yikes on that one. Sorry about that, folks. we're heading to Phobos. Mars has two moons, Phobos and Deimos. They're sort of small and potato-shaped. And Phobos in particular is the one that we have a good bit better resolution for, simply because of how different spacecraft have sort of approached near it and have different orbits that get close to it. This moon is actually the closest orbiting moon that we're aware of in the solar system, and it orbits around 3,700 miles away from Mars, which is really, really, really close. You're looking at about 238,000 miles away for our moon. So this is very, very, very close by comparison. I'm trying not to get too close because of the way our software works. It wants me to land on the moon if we get too close, and then it sort of pops out of view. So that's why I'm treading delicately here. You can see this cratered region in here, and this is an enormous chunk of the moon, and it looks like this huge, huge crater. And it's not small, certainly, but for some perspective, it's about 6 miles in diameter. And it's named Stickney Crater, and it is probably the most predominant feature on Phobos. Phobos is of interest to us as explorers because it could actually provide a very nice sort of stepping stone, since it's a small moon, a small stepping stone in a way to get us down to the surface of Mars and sort of set up shop in a place that's relatively safe outside of Mars and not dealing with any of the sort of mess of trying to land on Mars. It's a lot easier to land on something with much less gravity. And because of how fast it orbits Mars, and because of how small it is and how close it is, it would be, for about 2/3 of its orbit, or 2/3 of its day, rather, we would be very nicely shielded by Mars from things like the sun, and that would cut down on radiation exposure, and that's a nice thing. But gravity is an issue here, because you would be about 1/1000th what you weigh here on the Earth. So let's say you weigh 150 pounds on the Earth, you would weigh about 2 ounces on Phobos. So you would be very, very light and can almost jump off of it. And I guess for further sense of perspective, you're looking at about, I don't know, maybe 12 miles in diameter, something like that, depending on how you slice this sort of potato. And it's small and not very exciting, honestly. It is getting closer to Mars, and every 100 years or so, it actually gets about 6 feet closer. And eventually, in the next maybe 50 million years, we'll actually crash, spiral into Mars, and become part of it, possibly even bursting up some temporary rings. So that could be kind of cool. So 2 moons for Mars, Phobos and Deimos, small and potato-shaped. That's about it. Let's head to Jupiter. All right, so we have a few more people chiming in. We had Ganymede already, a couple people for Titan, and Rosanna says that the supermoon was beautiful in Peru, and like I said, I totally agree with you. Supermoon is always pretty. The moon is always pretty in any regard. As we head closer to Jupiter, Jupiter is a place that has a lot of moons. Certainly compared to Earth's 1 or Mars's 2, you can see very faint rings that we just sort of flew into. All of the gas giants do have rings. But yeah, Jupiter has a lot of moons, so let me show them to you. 79. So Jupiter has many, many moons, like I said. And they're mostly small. They're mostly captured asteroids from the asteroid belt, which is situated between Jupiter and Mars. And they're captured because Jupiter is sort of the gravitational monster in the solar system that isn't named the Sun. And so anything that gets a little bit too close to Jupiter at least gets disrupted, and sometimes it captures some things. So it has lots and lots of small things orbiting it. It also has some big things orbiting it. So let me pull up some different colors in here on a few of these moon orbits. You can see 4 of these orbits have colors now. The innermost colored one is orange. That is the moon Io. Purple here represents Europa's orbit. Green represents Ganymede's orbit. And cyan is representing Callisto's orbit. Let's jump into Io first. So these 4 moons are called the Galilean moons because they were discovered by Galileo himself. And you can actually see these with a very small telescope or even binoculars as pretty bright points right off to the side of Jupiter. As we tread over here to Io, let me turn off these moon orbits behind you. Io is the most volcanically active location in our solar system. Like ridiculously active, hundreds of volcanoes, very, very, very prominent volcanoes that can extend up to maybe, I don't know, 250 miles. The plumes can extend up to about 250 miles above the surface. You can see a representation of one in here, roughly to scale as well. Let's get on the limb so we can see it a little bit better against the background sky. And the bluish color of the plume is consistent with the presence of sulfur dioxide, which loosely envelops the moon. It's not, I wouldn't say it's an atmosphere, but it sort of gets released and then dissipated by all of these volcanoes. And the sort of yellowish is the result of sulfur in good amounts on the surface from these noxious plumes and lava and all that fun stuff. So it's quite a turbulent world. It looks like some moldy cheese or some pizza or something, and that's interesting to say the least. But yeah, definitely a dynamic world and very, very, very volcanically active. So I guess one of the questions could be, how does it get to be this way? And very, very fair point. And we have a good bit of what's called tidal heating. Tidal heating is where you have these different gravitational perturbations in your orbit, different gravitational tugs from the thing you're orbiting around, in this case Jupiter, and which we just flew through again. We're having a tough day with hitting things, I guess. So you are tugged on by the main thing you're orbiting, that would be Jupiter, and then you get these orbital resonances with other fellow moons as well. And so the result is that you get tugged in different directions, and there's sort of a rhythm to it, and it causes a lot of internal stress and a lot of friction in the interior, and it also heats up the interior through friction and these sort of pumping energy in through these resonances, and this causes a lot of internal heating, and in the case of Io, it's extreme, and things get so hot that you have this molten iron and sulfur dioxide and all sorts of other things that just get spewed out into space in crazy fashion. We're coming over to Europa now, which is another moon of Jupiter. And this one looks entirely different from Io. It has a very icy surface. It's a very, very flat, smooth surface, even though it has these cracks in it. It does have cracks, but they're sort of iced over as well. So it's a very, very smooth sheen. And if I pop it open, which I don't recommend you do at home, if you look in the middle, it has this sort of iron, or at least a rocky core, rocky mantle, and then what appears to be liquid water ocean. And we think that in the same way that Io is being heated tidally, the same thing is happening to a lesser degree on Europa, and this is allowing for a substantial ocean to exist, an ocean that contains more than 2 times the water of all of the Earth combined inside of this world, which is just a touch under the size of our own moon. It's about 90% the size of our moon. Io's a little bit bigger than our moon, for perspective. So if we look at the crust here, it's maybe 10 to 15 miles thick, but this ocean could be some, 40 to 100 miles thick, and very, very substantial indeed. So that would be a tremendous amount of water in a place that's not very near us. So that's very neat because it's an interesting example of a place that could be habitable outside of the Earth. Habitable by means of not you and I, but maybe salt-loving, cold-loving, water-loving bacteria, which is maybe not who you want to hang out with on a day-to-day basis, but that could be interesting. So we should go study it, and we're planning to. There's a mission called the Europa Clipper, which is going to launch soon, hopefully, so you can check out more on that. So we just had a question, well, a comment and a question. One is, that moon has to smell pretty nasty, referring to Io, and absolutely yes, it would smell like rotting eggs. That's no good. Secondly, Dustin wants to know what the requirements are for a moon, and I think that is a great question, but I'm going to put that on hold for just a moment until we get to Saturn, because it's worth talking about there. Let's head to Ganymede really quickly, hopefully not by way of Jupiter, but always a fear, I guess, and not looking too promising. Awesome. All right. 3 for 3. Okay, so Ganymede is the largest moon in our solar system. Jupiter's the largest planet, and it makes sense that it has the largest moon. And it looks like my buttons are mixed up because this is actually Callisto. So Callisto is the 3rd largest moon in the solar system. It is one of the slowest forming bodies in the solar system. Like I was saying before, all these worlds formed around the same time at the formation of the solar system, some 4.6 billion years ago, something like that. And the moons would have formed, in most cases, with their host planet, and they would have formed from basically the refuse that didn't get formed into the planet. Well, in the case of Callisto, you have a world here that took a really long time to actually sort of accrete and clump together. And so the result of this, maybe a 100,000-year formation, is that it's not very well differentiated. And I've been trying to make this presentation a little bit less technical than last week's about the sun. But this is a bit of a complicated idea, and it's basically just that if you have everything clumped together very quickly, things that are heaviest are going to sink towards the interior while things are still sort of molten and not cooled off and solidified. All right, so heaviest things are going to sink towards the center due to gravitation. If you have things form slowly and sort of chunk together, and it's a very slow process, then things can cool before they can differentiate and kind of heavier things settle out. So the result of this is that this is the slowest forming moon, and there are just weird pockets of material that don't really, there's not a nice like cohesive change in substance like you see in most places. It's just sort of chunked together. And it is a world that we don't know a lot about because we haven't sent many spacecraft near where they can actually get good pictures of it. But you can see a very large impact region here, and not even so much impact region, you can see the sort of reverberations from that impact that have cracked and shattered the surface around it, all those concentric rings. Very cool. Okay, let's zoom away and now head on to Ganymede, this time hopefully not by way of Jupiter, and I'll relabel my buttons for the next presentation. Let's see, so we have a question, how, and if you can elaborate, then I can answer. All right, so this is bringing us to Ganymede, and Ganymede, like I said, is the largest planet in the solar system, or the largest moon in the solar system, orbiting the largest planet in the solar system. And where Callisto was very slow to form, Ganymede was very quick to form, about 10,000 years, as opposed to 100,000 years. and it is very well differentiated. It has an iron core, and it's the only moon that has its own magnetic field, its own magnetosphere. It also likely has an internal liquid water ocean, just like Europa, and possibly Callisto as well. And it is a place that is so big, it's actually larger than Mercury by about 3%. It's much less dense, it's a lot icier than Mercury, but it's actually bigger than Mercury by a little bit, so funky stuff. In the interest of time, we're going to continue on. And I do want to point out, and maybe Aaron, you can link to it in the comments, but if you go to NASA's solar system website, they have all sorts of information about lots of moons, and you can learn more there and explore them a little bit further. So that's lots of fun. Okay, we're going to journey to Saturn now. And if you haven't seen it, you can go back and watch our Saturn video from a few weeks ago. That was a lot of fun and has some beautiful imagery in it, to be sure. So Saturn is actually now the king of moons, because where Jupiter had 79, Saturn actually has 82. And this is, if this number doesn't sound right to you, it's a fairly recent discovery, or sort of realization that we have 82. And this was announced maybe in October of this past year, up from 62. So we had 20 new moons named. So this begs the question, what does it mean to be a moon? How do you get a moon status? How is a ring differentiated from a moon? That sort of thing. And in the same way that our understanding of a planet is sort of arbitrary and not very well defined, a moon, the definition for a moon is even less defined. It's basically an object that is in a stable orbit around another object that isn't the sun. So it's something, it's an object, a world that is orbiting a bigger world where that bigger world is orbiting a star. So you can have a moon of a planet, you can have a moon of a moon in theory, you can have a moon of an asteroid or a comet, and of a dwarf planet, all these things, and we found most of these things. So that's sort of neat. There was a question, how big is Callisto in comparison to the Earth? And it is, they're all smaller, all moons in our solar system are smaller than the Earth. Callisto is probably close to about 1/3 of the size of the Earth, something like that. Maybe a touch less than that. So anyway, what is a moon? A moon is something that's in stable orbit around this world, and that's a really hard thing to quantify, because what does stable mean, and how do you tell that with very few measurements, right? So stable isn't like, 5 minutes or 1 year or even 100 years. It's sort of like an indefinite, this is going to remain in here unless something crazy happens, some outside force interacts in some way that causes it to leave. So the observations of these 20 new moons actually occurred in 2006, 2007, that time range, but they were only recently sort of remodeled and better understood, reanalyzed to determine that they were actually in stable orbits. And so from there, we were able to get an idea that yes, these 20 do fit the bill, and they were all added. And here we go, 20 new moons. I'm going to colorize those for you. Hopefully you can see that. And the different colors mean different things. Green is a prograde orbit, whereas red is a retrograde orbit. And the difference is that prograde means you're orbiting in the direction of spin of the planet. Retrograde is opposite of the spin of the planet. And the reason this is of interest is because retrograde orbits typically mean something that's captured, but also anything that's not on plane with the world typically means captured as well. So anything that formed with the world itself is usually on plane with it, more or less, except in some strange cases. And things that are sort of all over the place and very high inclination, kicked up in different ways, those are typically captured in some fashion. So I was expecting to go to about 15 different moons, and we're getting a little bit lengthy here. So I'm going to jump over to Titan. We'll take a quick look at Enceladus, and then maybe Hyperion, and call it a night. So as we jump over to Titan, Titan is the second largest moon in the solar system after Ganymede, and it was named Titan because it was thought that it was the largest planet in the solar system, and there was a little bit of ambiguity because of its atmosphere. Titan is the only world, or the only moon in our solar system that has an atmosphere that is dense and stable. It's actually a thicker atmosphere than the Earth's. It's about 1.5 times the Earth's atmospheric pressure. This atmosphere is largely hydrocarbons like methane and ethane, and some nitrogen as well. And we also see this methane and ethane in action on this moon as well. So when you're looking at this and you see the haze, that's the atmosphere. But then these darker regions in here are actually systems of lakes of liquid methane. So some very funky things are going on here. Just like we have a water cycle on the Earth, Titan has a methane cycle. So these different hydrocarbons rain, they precipitate, they rain, they snow, they evaporate into clouds, and there are seasons here as well. And we see the different fluctuations in these liquid levels of the lakes. There are probably underground rivers connecting some of them, underground reservoirs as well. There may be liquid water inside of it, but it's a very interesting world, a very unique world in our solar system. And we're planning to send an octocopter back to go visit and sort of explore it. So we're going to fly around Titan with an sort of an 8-rotor robot and zoom around. It's called Dragonfly, and that's launching maybe 2026 or so, and should be really, really exciting. So stay tuned for that. So let's jump over to Atlas. We've looked at a lot of round moons, and we looked at some funky moons of Mars that were sort of potato-shaped. Let's go inside of Saturn's rings, one, because that's a beautiful thing to do, and let's take a look at a moon that looks a lot like a UFO. So I don't remember if we went to this in the Saturn show or not. We definitely went to one called Pan. They both look very similar. They both look like some sort of unidentified spacecraft. A little hamburger patty or something that's a little bit weirdly shaped. What's going on here is that these moons are inside of Saturn's rings, and they're actually clearing out an orbit, and some of those soft ices in Saturn's rings actually stick to them, and they make this sort of disc shape of these soft ices clumping on sort of a rockier core area, and it's a weird thing. So this one's called Atlas. It's about 9.5 miles in radius, so just under 20 miles across, and it sits about 86,000 miles away from Saturn. Quite nifty. We're going to jump over to Mimas now. And Mimas is a pretty small moon. It's only about 226 miles in diameter, something like that. So not much whatsoever. But this moon may look a little bit familiar because it actually is a moon. It's not no moon. It is a moon, but it sure looks a lot like the Death Star. And that crater in there looks like it's going to obliterate you, but luckily it isn't. This crater is called Herschel Crater, named after William Herschel, who is the astronomer who discovered Mimas back in the late 1700s, 1780 something maybe. And this is, I believe, the 7th moon of Saturn that was discovered. And you'll notice that we have decent imagery of it for how small it is. And this is all thanks to the Cassini spacecraft. And we've got some pretty stunning views. Now I'm going to jump over to Hyperion, because this world is very strange. It is deeply cratered, and it looks kind of like a sea sponge. It's really unlike anything else that we see in the solar system. It's not something that we understand a good bit about. It's strangely ellipsoidal. It's this weird sort of egg shape. And it's maybe at longest 225 miles across on the longest axis, but you can see something that is, again, very, very spongy looking. And actually, I feel like this 3D model probably doesn't do it very good justice. It's worth you looking at pictures of it. Maybe Aaron can link to a picture of Hyperion as well. It's very strange. But it's a very, very porous world. It's very, very low density. So it's a very, very icy place. And while it's the largest, or second largest maybe object in the solar system not to be in hydrostatic equilibrium, it is one of, or it's, I think, the largest to have such a low density. Or it's, I guess, the least mass for its size. So very, 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 very low mass world, very, very icy, very, very porous, very, very strange. All right, so to wrap up for tonight, we're going to jump over to my favorite moon, which is Enceladus, or at least one of my favorite moons. And Enceladus is very similar to Europa in many ways, but Enceladus is a world that is very fascinating because we've had great opportunity to explore it with the Cassini spacecraft, and further, we are able to get a nice understanding of what's going on at its south pole and really inside of it. There, again, is this global underground liquid water ocean, very, very salty, lots of hydrocarbons, that is sort of stimulated by this tidal heating. We have these tremendous plumes that emanate away from the South Pole, about 100 plumes that we've counted. They're modeled here to realistic scale, orientation, location, that sort of thing. And there are these plumes of water ice that spew out from the South Pole hundreds of miles out into space and actually help contribute to the E ring of Saturn, which is this really thin, diffuse ring. Very, very funky. And I'll bring those off, but let me pop Enceladus open for you. And you can see a similar scenario to what we saw with Europa, this nice underground ocean in here. And it's something that is very, again, not very well known, but probably the best known in the solar system. We're able to actually get an idea of what composition is because the Cassini spacecraft was able to fly by it. And let me give you a quick representation of that. So on 27 separate occasions, the Cassini spacecraft was able to fly by Enceladus and collect data, which is a lot better than we can say for pretty much any other small moon in our solar system. This is like, let's say, 313 miles in diameter, something like that. So that's about half the width of Texas, maybe. And we were able to go by it 27 different times, but on October 28th of 2015, it made its closest approach at about 28 miles above the South Pole. And the spacecraft actually flew through these plumes and was able to taste them, essentially, with its instruments and determine that they were indeed hydrocarbons, hydrocarbons that we find in life, and that this was water ice that was spewing out. And when you have water ice and you have well, liquid water as well, you have an internal heat source of some kind, and you have these hydrocarbons. These are prime locations, prime elements, ingredients for life as well. So just like Europa, Enceladus and Europa are probably our two best habitability options outside of the Earth for things like bacteria. And we haven't found them, but again, if you're a salt-loving, cold-loving bacterium, this could be quite the vacation spot for you. So sort of a neat thing. Dan said those are crazy ice jets, and I agree completely. They're super, super cool. So with that said, I think it's time for us to wrap up. If you have any other questions, please post in the comments, and we're happy to get back with you. Thank you for joining me for conversation about the various moons of the solar system. We only hit a few, but there are over 200, including moons of dwarf planets like Pluto, and even asteroids have moons on occasion. The asteroid Ida has a moon named Dactyl, and that's sort of funky. So moons can be all over the place. And like I said, I hope you enjoyed it. Remember that science never stops, not at the U.S. Space and Rocket Center, nor anywhere. And my name is David Weigel, and I hope you had a great evening, and come see us again next week. Take care.